Hello all, welcome to our video on software design patterns. This video is intended to help you to become a better programmer and a good software designer. Some knowledge of UML class diagrams will be helpful along with working knowledge of C++ or Java-like object-oriented language. In this session, we will be using the following reference: Design Patterns, Elements of Reusable Object-Oriented Software by Eric Gamma and others, also known as Gang of 4. Design patterns promote code reuse and help solve design problems associated with finding and creating appropriate objects, structure the code to appropriate level of granularity, and implement behaviors and interfaces. Design patterns fall into three categories: 1. Creational patterns. 2. Structural patterns. 3. Behavioral patterns. Creational patterns help design and create classes and objects. They provide flexibility in object creation process, such as when it is used, how it gets created, and who creates it. Creational patterns are 5 in number. They are: 1. Factory method. 2. Abstract factory method. 3. Builder. 4. Prototype. 5. Singleton. Of the above, factory method is a class pattern only, others are object patterns only. The next set of patterns, structural patterns, help structure classes and objects. They help to structure interfaces, implementations for classes, and to compose objects into larger structures. Structural patterns are 7. They are: 1. Adapter. 2. Bridge. 3. Composite. 4. Decorator. 5. Facade. 6. Flyweight. 7. Proxy. Of these, adapter is a class and object pattern, others are object patterns only. The final set of patterns, behavioral patterns, deal with the ways how classes and objects behave and interact. They focus on patterns of communications between objects. Behavioral patterns are 11 and they are: 1. Interpreter. 2. Template. 3. Chain of responsibility. 4. Command. 5. Iterator. 6. Mediator. 7. Memento. 8. Observer. 9. State. 10. Strategy. 11. Visitor. Are you ready to look at the patterns in detail? Let's do it. Okay, let's look at the object creational pattern, the abstract factory. It provides an interface for creating families of related or dependent objects without specifying their concrete classes. Use this pattern when you want to create families of related objects, where each family is a set of classes derived from a common base. Concrete classes should be decoupled from clients. Libraries must be published without exposing implementation details. The next is a class creational pattern. The factory provides a method for creating objects, allowing subclasses to control the actual creation process. Use when subclasses may specify what objects should be created, or parent classes wish to defer creation to their subclasses, or a class will not know what classes it will be required to create. It is a lightweight pattern that can connect parallel class hierarchies. If each hierarchy contains a factory method, it can be used to create instances of subclasses. The next object creational pattern, the builder, separates the construction of a complex object from its representation so that the same construction process can create representation. Use when you need fine control over construction process, or the algorithm for creating parts is independent from the parts themselves, or the object to be assembled might have different representation. Builder pattern can be found in applications that create complex structures. The result of a builder is often a composite. The next object creational pattern, the singleton, ensures a class only has one instance, and provide a global point of access to it. Use when you need to ensure there is only one instance of the class, or you want clients to use the extended instance of a subclass without code modification, or you might need more than one instance at a later stage. Though singleton is a simple pattern, the result could be complete mess if standard rules are not followed, like in case of two developers, one uses an instance and another uses a create method. The final object creational pattern is the prototype. To specify kinds of objects to create using prototype instance and create new objects by copying this prototype. Use when you want to hide concrete classes from the client, or add and remove new classes via prototypes at runtime, or adapt to changing structures of data at runtime. The prototype co-opts one instance of a class and uses it as a breeder for all future instances. To recap the creational patterns. To create a family of objects or related objects with an abstract interface, use Abstract Factory. To allow subclasses to control the actual creation process, use the factory pattern. To have only one instance of the class, use Singleton. To create objects using prototype or add or remove classes at runtime, use prototype. To construct a product by step-by-step algorithm, use Builder. Thanks for watching. Watch our next presentation for structural and behavioral patterns.